Guys, let's have a look at the next topic. The next topic is actually the second part of a topic we've seen before, quadratics. And in this one, we're going to focus more on the theoretical aspects of quadratics, i.e., solving them and looking at certain parts of a quadratic equation. This is something that will really prepare you for higher mathematics. So when we're looking at this, what we're looking to do is we're looking to solve equations either graphically or through algebraic means. The first bit here, and it won't take as long to just go through this, when we solve quadratic equations graphically. And that's really just us looking at the equation and then solving it through inspection. When you solve a quadratic, you're actually finding the roots. Okay? So when you find the roots of a quadratic, that's the solutions. Sometimes they call it the zeros. It's more common to be known as the roots, or where it cuts through the x-axis. Okay? So remember, linear equations, that's your basic equations that only have an x term, they only have one solution. Quadratic equations where there's an x squared term can give up to two solutions. Okay? So there can be two solutions, there can be one repeated solution, or there can be no solutions. And what we need to realise here is that a quadratic, it's got the form ax squared plus bx plus c equals 0. And in order for us to solve a quadratic equation, we have to make sure that the right hand side is equal to 0. Okay? That's a fundamental rule here. We have to make sure that our right hand side has a 0 on it. So everything has to be on the left hand side. Okay? The grey box here just tells us what I was just saying there, that the solution of a quadratic equation is the same as the roots of the quadratic graph. And the roots of a graph of the equation at the points where it cuts through the x-axis. So just remember that, and always remember that it cuts through the x-axis whenever y is equal to 0. Just remember me banging on the desk saying that over and over again. So if we were to look at this quick example here, this parabola is the graph of y is equal to x squared minus 3x. Okay, so the quadratic equation, x squared minus 3x. We can solve this quadratic equation just by looking to see where it cuts through the x-axis. So this parabola cuts through the x-axis at 0 and 3. So the solution to it is just going to be x equals 0 and x equals 3. It's just purely inspection. That's it. That is the solution. End of story. Okay? We will come back to quadratic graphs a bit more when we've done some work on factorizing and looking to solve it using the quadratic formula. So let's have a look at the first bit here. So the first bit of solving quadratics by factorizing. You'll remember that in the last topic when we spoke about sketching quadratic graphs, we actually did a little bit of solving quadratics because you have to do it in order to solve them. So a more common way to solve quadratic equations is to use algebraic methods. The first one we're going to look at is factorizing. Then we'll go on to something that's called the quadratic formula, and then on to completing the square. Okay? To solve a quadratic equation, using factorizing, we have to make sure that the answer to the multiplication problem is 0. So again, the right hand side equals 0. So whenever you're solving a quadratic equation, once you have it factorized like these examples here are, in order for the equation to work out, one of the terms has to be equal to 0. So the first one we've got here is x minus 2, x minus 3 is equal to 0. So what this means that in order for the right hand side to be 0, one of these brackets has to be equal to 0. So it's either going to be x minus 2 equals 0 or x minus 3 is equal to 0. It doesn't matter which one it is, we just set them both equal to 0 in order for that to work out. And then all we do is just solve them independently. So if x minus 2 is equal to 0, that gives us x equals 2. And if x minus 3 is equal to 0, that just gives us x is equal to 3. Okay. So again, the ones in this example here, they've already been factorized, so we can just go ahead and do what we did here. So the first one here, it says x bracket x plus 1 equals 0. So that means that either x is equal to 0 or x plus 1 is equal to 0. So that means that x has to be 0 or x has to be equal to negative 1. Okay. The second example, we have x minus 5 in one bracket and x plus 3 in the other bracket equal to 0. So that means that x minus 5 is equal to 0 or x plus 3 is equal to 0. So that means that x is equal to 5 and that x is equal to negative 3. Okay. The next one here, we have 2x plus 5 and 3 minus x equals 0. So it means that 2x plus 5 is equal to 0 or 3 minus x is equal to 0. So solve them one at a time. So that would give me 2x is equal to negative 5. So x has to be negative 5 halves. The next one is minus x is equal to minus 3. So x has to be equal to 3. And what we're actually doing here, remember, if we go back to thinking about solving these graphs graphically, or solving the equations graphically, I should say, we are solving to find the roots. So even though it's not required here, looking at this first one, if we've got x bracket x plus 1 equals 0, and it's cutting through the x-axis at 0 and minus 1, that roughly means, and this is not an exact graph, this is only a sketch, that means that my parabola is going through here at 0 and through here at minus 1. The second one, it means that my parabola is going through here at minus 3 and going through here at 5, and it will look something like that. Obviously, this is really not to scale. And for the last one here, it means that it's going through here at minus 5 halves, which is just minus 2.5, and through here at 3. Okay? That should not be new to you. Okay? In the next video, we will look at actually having to factorize them in order to solve.